Welcome to the Uptime Podcast. We have a packed show this week. Top of the list, Vineyard Wind finds a bomb on the ocean floor.
And GE have shelved plans that they had to make a new factory to supply the Dogger Bank wind farm in the UK, while Enercon in Germany have received 500 million euros in state liquidity assistance.
After that, we'll speak about some wind energy shutdowns here in the Midwest over in Minnesota, and then how they tie together with the Mid-Continent Independent System Operator, otherwise known as MISO, to expand the power lines and to try to alleviate that bottleneck.
It's going to be a busy week, so stay tuned. We'll be back after the music. All right, so the first story for the week, Vineyard Wind, which is off the coast of Martha's Vineyard in Massachusetts. They're evidently exploring the bottom of the seafloor, looking for places to put wind turbines, and they happen to stumble across an unexploded ordnance. It says here that the Hornbeck Offshore Services support vessel, Mystique, uncovered a potential unexploded ordnance at about 130 feet of water. Now, why this is important is evidently back in World War II, that whole area was used as training grounds. So there's all kinds of ordnance down off the coast of Martha's Vineyard. In fact, I started digging around a little bit, and I guess some of that ordnance just washes up on shore once in a while. So you could just be walking your dog on the beach, and there's an unexploded piece of ordnance right on the beach, right? Yeah. So it sounds like it's a pretty significant issue. So this is the first warning I've seen, and Vineyard Wind actually puts out these alerts like, "Hey, everybody, there's a black hole or unexploded ordnance or some sort of great white shark or something out in the water." I don't know why the coast of Massachusetts is so treacherous, but it is right now. It's crazy. We have some of the biggest great white sharks. I mean, we would hold our own up to Australia for sure. These things are massive, and they've been attacking people lately. It's like a real life Jaws out here right now. You can honestly say that. But now you got Jaws, and you have this unexploded ordnance. It's like this Godzilla movie thing that's happening. I don't know if you saw the last Godzilla, but that's how they woke up Godzilla. They set off a nuclear weapon.
Shark.
Yeah, so sharks. And
Sharknado.
Sharknado, exactly. We can have a Sharknado in our own backyard. So I'm expecting to see more of this, and especially as we start going up and down the coastline around Long Island, New York City, New Jersey, even all the way down to North Carolina. I think there's going to be all kinds of ordnance out there that we haven't really thought of before that we're going to have to pay attention to. Joel, I mean, you've probably seen some of this stuff. What do you think?
Yeah, I mean, depending on who you talk to and what organization you talk to, it's something between the level of 70% to 90% of the seafloor in the world has never been mapped, right? So there's so much stuff down there that we don't know about. Now, all the operators that have been putting in offshore wind over in Northern Europe, they've been doing the same thing. So you got to there's a bunch of stages to it, right? So you're going to do a geophysical campaign. So you just map. You're going to ping with sonars, build a 3D elevation model of the seafloor. And then sometimes you're going to go down with magnetometers to find any kind of, unexploded ordnance, metal, steel, anything like that might be just on the surface or on the subsurface. And then you're also going to come with like a near surface geophysical campaign to look for boulders, how deep the muck is, and then the sand is, and then the bedrock is, and all this stuff. So there's a huge campaign that happens before any of these things get installed out offshore. And this UXO here on the coast of the U.S., I think people will be surprised at how many we will find as we move forward here. I mean, it's a daily occurrence in a mapping of a wind farm over in Northern Europe, but World War II, right? Bombing back and forth across the English Channel. We get that, but there's also going to be some pretty cool, I would imagine, shipwrecks and other things that we'll find that we haven't seen before, because it's the massive scientific campaign to map the seafloor and the sea subfloor down to a couple hundred meters is going to be unprecedented off the East Coast and wherever they do offshore wind.
Well, you'd think all the treasure hunters would be really following this very closely, because I think that's how they found some of these treasure ships, right? All the off the coast, and particularly South Carolina, North Carolina.
Mm-hmm. There's a couple out there, and I know some of the cool they found. I just read this not too long ago. It was a frigate, they called it, but it was basically a steel armored ship from the Civil War that they found off the coast of North Carolina doing one of these surveys. Right, so it was because it was covered partially by the seafloor. You never saw it when a fisherman's sonar goes by, but when you run a magnetometer, all of a sudden you got this big glowing hot spot on your map. What is this? Let's go investigate it, and that's what it was.
Did this sort of scans also happen when we get to floating wind? Like how deep can they scan? Oh, really?
Oh man. Yeah, because the big thing with floating wind, of course, is when we go to either drive piles or set anchors for mooring chains. Right. So not only is there the remote sensing part of it, but there's a physical geotechnical campaign that has to do drilling and bore samples to understand what kind of soil is there. So can the anchors hook? Are you going to need a 20-ton anchor here, or are you going to need a 1,500-ton anchor? What are you going to need? Are you going to be able to do subsea micropiles? How are you going to do this thing? So all of that geotechnical and geophysical investigation has to happen no matter where you're going to install anything offshore.
Wow. So there's a lot of work to do before we get to floating wind. And California, I would assume the next stage is California, then the Gulf. But California, from World War II, there's all kinds of ordnance dumped off the coast of California because they're trying to protect the coastline, right? Just like they were on the East Coast. So, but there's it drops off. The continental shelf drops off so fast that it's going to be almost all floating wind out there. So they got a lot of work ahead. Yep. I mean, they could probably have years of scans to go.
Oh yeah, and so when you go geophysical campaign in deep water, if you follow that technology sector, there's a lot of really, really cool companies coming out with what they call an AUV, which is basically a drone for the subsurface, right? So these things can be rated 1, 2, 3,000, 4,000, 5,000 meters of depth rating. So to get the resolution you need on the seafloor, they'll take them and they'll have like a mothership. This is a lot of what's going on now. Drop one off, and then that mothership will communicate with it acoustically and then guide it subsurface. So if you're in California in 1,500, 2,000 meters of water, that AUV is actually 100 meters off of the seafloor, mapping it at high resolution while the ship above is controlling it wirelessly.
Wow. Yeah. And that'll be the first time where we've really done a really deep, thorough scan of some of these areas, I'm sure, particularly of California.
Yeah.
Wow.
Yeah, exactly. And so that's there's not that much mapped, right? In oil and gas areas, of course, this stuff has all been done. Sure. But we're not installing a lot of offshore wind on top of subsea oil and gas infrastructure.
Right.
I hope not, at least.
Yeah. Well, it's an interesting development, and I'm just keep thinking we're going to find all kinds of unique items at the bottom of the ocean floor. And speaking of oceans, GE, Rosemary's old stomping grounds, was in plans to build a blade factory. Again, something Rosemary was heavily involved in on Teesside, which is on the eastern side of England. And it's a port area, and the goal there was to create blades and then ship them off to sort of Scotland area in the North Sea for these big wind farms, Dogger Bank being one of them. And GE had committed about the middle of last year to do this project, and then it came about Christmas time, and you could see things had slowed down quite a bit, and they just announced that they're not going to take over that factory. So there's existing buildings on this site, an old steel factory that GE was going to take over and use to build blades. And it really tells you how fast this market is changing, because GE only has one confirmed order in the UK for their Dogger Bank complex, while Siemens Gamesa keeps winning job after job after job over there. And so in that kind of fluctuating environment, Rosemary, how does GE deal with this? I mean, how do you project out in the future? I guess you don't build factories. I guess you take over existing factories. Maybe that's the approach now, like GE did. Like, if there's a factory there, I'll take it. If I don't need it, I'll just walk out of it, instead of putting in, $40-50 million into it.
Yeah, I mean, I'm sure that there would still be a huge amount of investment to make it suitable for making wind turbine blades rather than steel. And I don't know how many buildings there are that are big enough to make offshore wind turbine blades, because they're massive. I know it's not just the length, which, can be over 100 meters now. It's also the width, because you have to be able to rotate it. And if you've got the widest point of the blade is, well over five meters, you need to have a ceiling higher than that. And I don't even know what the very longest blades are, probably getting closer to 10 meters even in their widest point, and that's challenging to find buildings that are big enough. But I guess that they were trying to hedge. They want to be able to supply this huge market, but they don't want to have to pay to commit to that before they know if they've won the orders or not. And so it sounds like that's what they've done, which is no doubt incredibly frustrating for the local government and the people that live there and wanted those jobs. They probably thought it was quite certain. I know it's not winter's the only time that you see this. It happens every time in Australia that they want to open a new coal mine or something. They make this immense number of jobs that they estimate are going to be associated with it. And even when the projects do go ahead, the number of jobs is always reduced down to like 10% or less by the time it actually happens, because everybody knows that local communities want jobs, and that's how you get them on board, is by inflating the numbers. So I definitely got sympathy for people that thought that this was coming to their local area to help with problems they might have. But hopefully, Dogger Bank is still going ahead, right? It's just not GE that's going to be making as many turbines for it as I thought. So hopefully, if Siemens Gamesa is winning most of the contracts, hopefully they're going to, maybe they will need to ramp up their manufacturing in the area, or they'll see this opportunity. And there's still going to be work there associated with the wind farm.
I think Siemens they just opened a new factory. I don't know if it's new or repurposed outside of Hull.
Right.
For these offshore wind farms. So they're capitalizing on it. But
right. The Queen has visited there.
Second place.
The Queen.
Blessed it, or whatever the Queen does.
She doesn't go that many places
she
anymore, so that's a big deal.
I've seen pictures. It actually is pretty cool. Yeah, she's walking around in there. It's pretty awesome. And Rosemary, you're right. They were talking about making 750 jobs and another 1,500 in supply chain. So that's Teesside's not a very big community. So we're talking about 2,000 jobs. That's a really big deal. But there's actually two parts to this facility that exist in Teesside. The other part of the facility is going to be taken over by a South Korean monopile fabricator, basically a steel company that's going to be building monopiles there. So at least they'll have something in that factory, which is good. And with this latest Boris Johnson leaving office, you got to imagine that a lot of these UK tenders are going to get set aside for a little while, maybe. I'm not sure what's going to happen, because Johnson's not supposed to leave until the end of this year, when the next elections are. So we have several months.
Yeah.
Oh, September.
That's what I saw.
That early, okay.
That early? Is that early? I don't know. Maybe it is in the US. We have a similar thing in this.
Pretty soon.
In Australia, our government is maybe a little bit more similar to the UK than you guys are. Because we also have our head of state, our prime minister is chosen by the party, party and government. So obviously when you directly elect a president, then you know exactly when that's going to happen and when that's going to change. But in Australia, we went through, our last prime minister was the first one in over a decade to have served one full term, actually, from election to election. That was we had a decade of them just changing constantly, and it can happen like that, like one day you've got a prime minister and you've heard that people are a bit annoyed with the way that they're managing things, and then the next day there's a new prime minister who you might not even there's been plenty of times where I couldn't even pick out our deputy prime minister out of a lineup, for example. Who is this new person? What's going on? So to me, it feels very slow that, especially because the pressure has been on him to leave for so long, months and months. And now it's like, so we've all agreed that this guy's a dud and has to leave. And even he's accepted that now. but we've still got a few more months, a few more months of hanging around. That seems so weird to me. Like, what can you get done in that period when you already know people don't trust your judgment? That's the point. So, now you're just gonna hang around and make a bunch more decisions, and everyone's gonna work real hard to implement those. It's just so strange. Really strange.
I can't speak the same for the UK, but I know in the US, when we have a lame duck president or senators and whatnot, a lot of the things that happen in that period are more social than economic.
Mm-hmm.
Yeah.
So they're just trying to pass some cement some legacy stuff and yada, yada, yada. But the curious thing about offshore wind is it's in that intersection between social and economic. So maybe something will go, maybe it won't.
Yeah.
Just timing isn't on his side, I suppose.
The timing is bad. There seems to be a lot of turmoil. Have you guys been watching the Netherlands, the farmers in the Netherlands with their tractors protesting the changes there? It's just a lot of weird things happening simultaneously in Europe and in the United States. I'll throw us into that mix. That doesn't bode well for renewable energy projects, because if there's turmoil in other facets of life, that doesn't make governments very stable.
Yeah.
And they're not thinking long term. Typically, they start thinking very short term, but thinking about that next election, and all the long term projects just kind of get put on the sidelines until the elections are over.
But I do see
It seems like it's happening.
A lot happening. I'm certainly getting more inquiries than ever from Europe about clean energy projects that are going ahead, and a lot of them have EU funding, so maybe that's a more stable kind of way of funding things. And definitely a lot of things are moving forward, and everybody that gets in touch with me has a really ambitious time frame of when they want to achieve their plans. There is a lot happening there, and I've seen, in my tiny business, I've got way more as a proportion of people getting in touch with me. It's way more from Europe than normal. Usually it would be largely US startups, tech startups and investors, and now there's a lot of actual physical projects to install to use these technologies, all the new emerging energy technologies to build say a microgrid here, or making a traditionally polluting industrial process green somewhere else, or all sorts of different things. They're actually starting to organize construction projects to get these things in the ground fast. So I am noticing a bit of a change to the speed that things are happening in Europe over the last few months compared to the last few years. I see a change.
Have you been following on the Nord Stream gas pipeline, where it's down for maintenance at the moment?
I think it's
maintenance. There's some concern that it may not come back up again.
You need the inverted commas, the square quotes. Yeah, I think that's necessary in this case. Yeah, I have seen that, and I know that also I've seen that Germany is preparing to just cut the cord anyway, because they don't want that, because then they have to, right? I mean, when you know that it could get cut off at any point, better to feel the pain on your time frame rather than it to happen. And as soon as there's a cold snap, and then all of a sudden you get no notice and you've got no gas. I mean, they can build up their stores to a certain extent. No one's got that much storage, though. That's not enough storage to be like, oh, we're cool for the rest of winter now, and we can sort something else out before we run out. It's not like that. People have days of storage if they're lucky. Yeah.
It did seem like Germany was trying to store natural gas and whatever storage facilities that they had to prepare for winter. That's what it seemed like, that they were trying to stockpile. But Austria, I read, I think it was today, where Austria is going to bring back some coal-fired power plants that had been mothballed because they're concerned about this winter, and they need a little bit of time, like we discussed previously, a little bit of time to bring those back up to speed. It is a really changing energy front. Maybe Sunovate, maybe Glenn Ryan's company will get some action over in Europe, because it's a big improvement in solar efficiency with his idea. We're going to take a short break right here. When we come back, we're going to talk about 500 million euros that is a liquidity assistance to Enercon. After the break.
Get the latest on wind industry news, business, and technology sent straight to you every week. Sign up for the Uptime Tech newsletter at weatherguardwind.com/news.
All right, we're back, and Rosemary is going to give us her 2 cents on a 500 million euro, which is, I think the dollar and the euro are finally at unity once again. So I guess it's $500 million of liquidity assistance. So Enercon, which is one of the German wind manufacturers, the only one left, maybe? Is that the only one left in Germany? Rosemary? Is it just Enercon? Nordex?
Isn't Nordex German? I have to look it up because
Nordex may be German. I'm losing track here.
Yeah, it's headquarters in Rostock, management situated in
there you
Hamburg.
go. Yeah, I knew that. Okay.
It's a great city.
Oh, Hamburg.
Yeah.
Where we're going to be. Yeah.
I love Hamburg.
So Enercon is about to receive 500 million euros from the German federal government, essentially, and as part of their COVID support structure. And it sounds late to us. In the United States, all that sort of COVID support's already over. It's just what's causing really high inflation in the United States, combined with I think a recession, as all the money's been dumped into the economy. But I guess in Germany, they're still at it. So it's $500 million to Enercon. Now, Enercon says it's going through a transformation, and it's trying to basically break even for 2022 with the 500 million. So that indicates maybe Enercon is really struggling if it needs $500 million to break even. But you would think that it makes sense for the German economy to support Enercon. If it's Enercon and Nordex, combined with this requirement now that all the municipalities in Germany have to dedicate 2% of their land mass to wind energy, it seems like there's a built-in marketplace right in Germany at the moment. And does that make sense, Rosemary, that because they've just created a marketplace, that they need to keep the wind turbine manufacturers around? Yeah,
otherwise they're going to end up stimulating, foreign companies with that policy.
China, for sure.
Yeah, it makes sense.
Yeah.
I don't know if this is really related to the pandemic. Enercon has been in struggle town for a lot of years. And I mean, my personal take on it is that Enercon were way too German focused for way too long. I mean, early on, that was just the absolute amazing best strategy to focus on the German market, because from the early 2000s for a while onwards, that's where not just wind but all renewable projects seem to be happening in Germany. But for a long time after, it started tailing off in Germany, and definitely, like, I spent quite a lot of time in Germany while I was living in Europe, because it's a nice country with great food, and did a lot of skiing there and stuff as well. You talk to people, and the sentiment around wind had changed a long time ago, at least a decade ago. People were not overall positive about wind, especially. I was spending a lot of time in Bavaria and down in the south there. I don't think they ever really liked it. And Enercon was really, really stubbornly, my opinion, that they were just stubbornly focused on Germany, on selling only to the German market and making everything in Germany. And they certainly have a reputation for being, like a really, really nice wind turbine, high quality. I know wind turbine technicians have told me it's like a Mercedes-Benz of wind turbines. When you know that you're going to be working on an Enercon turbine that day, you're like, it's like luxury inside. I've never been up one, but I know, talking with the engineers that I have worked with at Enercon, they're definitely not like good enough is good enough type engineers. It's like, let's optimize this and optimize that, and you end up with a premium product that maybe really suits a German engineering mindset, but wasn't as suitable for the rest of the world, who are much more focused on price. And as long as the quality is good enough that it doesn't, break down and cost you more money, then that's kind of more where, external markets are. So for years, they've been having problems keeping the German factories open because, it's more expensive than other manufacturers. Were moving offshore closer to the emerging markets. I mean, they were emerging back then. Now they're, mainstream, India, for example. I'm a bit skeptical. This has so much to do with COVID. I think it's just a continuation of problems they've been having. But maybe with this new policy that is going to bring a lot of German demand again, maybe we can go back to Enercon's original strategy of really serving that market. And, if there's local content laws, then that will really suit them, keeping their factories running, even if they are higher cost. So maybe it'll work out for a bit longer for them. But I would think that in the long term, they're still going to have to think further ahead than Germany and make it work, because eventually Germany will fill up, There's only a finite number of places that you can put wind turbines in such a densely populated place as Germany.
Do you think that the local geopolitical climate might have been another poke in the side to the German government to say, hey, you've got a wind turbine manufacturer here. We're going to be focused on renewable energy. Make sure they make it because we need them.
Yeah, I think so. I hope so. And I hope that all countries are doing that because, we can't just think about what's the lowest cost way to make this year. Now we're all like, okay, well, what are we doing to our supply chain security if we have these single countries who, I mean, even if they are friendly countries now, how can you say that's going to be the case in 5 or 10 years, So, I think there is going to be a shake-up and a more onshoring and countries making sure that they look after their own industry. At least I hope that they do that. I think that's good for world peace.
Rosemary, I was thinking of you the other day. I was watching Elon Musk, and don't kill me for this because I don't think you're a big Musk fan, but he was walking through his factory, showing off the rocket engines and talking to this amateur scientist rocket enthusiast as he's doing it. So he's like taking this guy around his rocket engines and showing him how the new rocket engines have fewer components than the old rocket engines. Like, oh yeah, okay, that makes sense. And he kind of chimed in saying, the first problem with engineering is you try to optimize things that shouldn't be there in the first place.
Yeah.
Like, do you really, really, really need this thing? And maybe the best situation is to remove it. And I think about Enercon sometimes because those turbines are so beautiful. I mean, when you see a wind turbine that looks really awesome, it's an Enercon every single time. And I think, well, it does look cool, but maybe it has that sort of mentality of we're trying to optimize something that doesn't really need to be optimized.
Yeah.
And that's maybe one of the reasons it hurts them. It's kind of like buying an expensive car, same sort of thing. I'm buying a Ferrari's like that, right?
Yeah, no, I agree. That's my...
I'd have to go check my three Ferraris.
Right.
That was definitely my impression working with the engineers there. And you can see, I actually think that they got an architect in to design that egg-shaped nacelle that they had.
Right.
They've moved, I think they did too. But they've moved away from that now. I don't know if they moved back, but it was too expensive and it didn't really do anything. I mean, the whole shape, they've got the blades, got the optimal aerodynamic design. Usually, a non-Enercon wind turbine, the blades are just like a cylinder at the root because, the blade's making torque, and torque is a force times a distance. So the closer you are to the hub, the closer that distance part gets to zero. And so the closer your torque gets to zero. There's very little to be gained by optimizing the aerodynamics there. And if you want the optimal design, because the blade's not turning as fast close to the hub, like that's, wind speed. So you need a huge chord to get the same, like the optimal amount of lift produced there and thereby torque.
Right.
So you have to add a lot of material, a lot of weight to get this, optimized aerodynamics, and everybody else is like, okay, this isn't, when you trade off all these different parameters, we find that, the best thing to do is just a simple cylinder at that point. But not Enercon. Enercon has the much more optimized aerodynamic shape than a cell. At least it used to be this, beautiful egg shape to to reduce the disturbance of airflow in the early parts of the blade. And it doesn't really give you a better overall turbine, but every individual part is optimized, So I do think that that's a bit like that. I'm not anti Elon Musk at all. Like, I don't think he seems like a guy I would like to be friends with, but I think he's doing really good things for engineering and, for the energy transition, and I ignore what he says on Twitter. I think that's I don't know why anybody does anything different to that. But I disagree that you could say, engineers want to optimize things that don't need to be optimized. I mean, I think it has a lot to do with your business structure. If you've got someone that's in charge of some component, that's, their whole team is organized around this one component, of course, that's what they're thinking of, and they're going to try and optimize that. It's up to the person in charge of the business to make sure that you've got your structure in a way that makes it possible to innovate across boundary lines. I mean, you can always tell like a company's business structure if you just look at their bill of materials and how, how the systems and subsystems and components are all broken down. That's a a company flow chart basically, or an engineering department flow chart. Right. Yeah, I would disagree that you should put the responsibility for that on the shoulders of the engineer whose job title is probably linked to the component that they're working on. They're not going to be thinking about, does this component need to exist? That needs to happen at a higher level. So, yeah, maybe he can take some responsibility for that. Let me ask you, if he's a chief engineer.
Well, that's just it. That the chief engineer is just what I was thinking, because that's the person usually in an engineering organization who's like responsible only to the head of the company. And their job is to go around and kick the tires and say, what are we doing? This doesn't make any sense. You're spending all this money on a piece of this hardware that doesn't add any value here. Do wind turbine companies have chief engineers anymore? It seems they had gone away in like the early 90s. No. Do they have people like that?
Yeah, they have. And I believe that Elon Musk is the chief engineer for all of his engineering companies as well, or at least a podcast I listened to implied that. But yeah, the company that I've worked for and with all had chief engineers, definitely. I mean, they're signing off on...
oh, really?
Yeah. GE has a lot of different chief engineers. Some of them were quite quirky, and you would know who you were going to run into at your design reviews. But yeah, definitely. I mean, mostly people are using a stage gate product development model. So he's got maybe like 5 gate points where the chief engineer has to get involved and sign off on the decisions that have been made, and they'll be looking at what's the biggest technical risks and what have you done to address those, and there's certain criteria that they have to meet before you can move to the next one. So yeah, I mean, I was doing product development the whole time that I was working at LM Wind Power, which was eventually GE. And so yeah, every month at least I would be in some design review with chief engineers, and it's an important role, and I really enjoyed working with the chief engineers.
it makes you wonder if that, and that maybe it's a European thing where that has continued on. I know I'm working on a lot of different programs, and chief engineers are really hard to stumble across. It used to be in any sort of serious design discussions, the chief engineer would be sitting at the end of the table, just absorbing everything that was going on and making recommendations at the end. But I haven't seen that in a long time. And it's a very odd person to be in that role, right? It's not an easy thing to do. Think about all the skills that you have to be able to do that. And it would make you sort of an odd person in a sense. Like, why do you know all this stuff?
Yeah.
Well, because they just absorb it over the 20 years.
It's someone who's got a long history in the company, so they have, a lot of knowledge about what's been tried, what's failed in the past. So part of the job is to make sure that you don't just try and reinvent the wheel constantly, and they can predict how things are going to break. I mean, to me, that's what I think, engineering intuition, or the difference between an engineer with 20 years experience compared to one with 2 years experience is that the 20 years engineer has seen so many things break that they know how things are going to break. That's, basically what you get when you get a senior engineer is the ability to predict things breaking. So, they're making sure that you haven't missed anything obvious, and they're usually making suggestions about, we tried this, sometime couldn't that solution work here, and they're just somebody that's not knee deep in the project day to day, so they can bring some sort of fresh eyes to it as well, usually. So I was going to say, like, aside from the chief engineer being in charge of, like big shakeups of the way things are done, I also think that brand new employees, especially ones from outside the industry, really should be tapped for that. And I know every time I would get a new teammate from outside, I take a brand new hire, before they do all the reading and go to meetings and start to absorb the culture, you want their fresh beginner eyes on a problem to point out, why do you do that? Say all the dumb, they think that they're dumb questions. Say all of those, because you're never going to get that again once you are absorbed in the company culture and you know how things have been done, and you kind of start to respect your colleagues and think that they've obviously made smart decisions. Before all of that, you want to be able to say, why did they do that? It seems like it would be easier to do it in this other way, or something like that. And I think that's a really crucial part of innovation. And that's something that I think that Europe doesn't do as well as the US, because I think in the US people are moving industry a lot more. Yeah, I think in Europe.
Oh, that's probably true.
In Europe, people have much more linear career paths. So they get really expert at one thing. And in America, it's much more common to get poached from another industry where they can see that you've got some things that will help. And people have seen a lot of different ways of doing things. And so you can get more innovation that way. That's my... That's my opinion about it. Engineering differences between the US and Europe.
Yeah, I think there's a big difference between the two. I think it's sort of cultural too, and that's what seems, in my opinion, what drives it. Japanese engineering systems are totally different than American engineering systems versus South American or European. There's a lot of cultural differences between those two, and that sort of sets the bar of like where the weight swings. Does it swing to the top of the organization or to the bottom of the organization, or is it kind of spread out? And there is no right answer. I don't think. It depends on the industry. It's just something that, as times get a little bit tougher here, you tend to lose people like chief engineers because they're expensive. They'll be the ones that kind of, you lose that top and you lose the bottom. Everybody in the middle that's kind of doing the thing will be the ones who stick around typically. So it's going to be an interesting couple of months here. We're going to take a quick break. When we come back, I want to talk about power line congestion. And it's a big topic in Minnesota because some of these counties are losing thousands and thousands of dollars on tax revenue. And what part of the United States is going to do to try to remedy this situation. So we're going to be right back after this short break.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
All right, power line congestion in Minnesota. You would think to yourself, well, Minnesota, it's not the biggest of states in the world, right? And it's a decent-sized state, but it's about the size, it's about the size of England, maybe a little bit bigger. But it's not it is
that
roughly.
That makes it sound
right?
really big.
Isn't Minnesota like half the size of England?
England's a whole country.
England's not that big of a place either. Yeah, but you could drive across it in a couple of hours. This isn't like Texas where it takes you a whole day to get across. Come on, guys.
Yeah, I think you could drive from the southwest corner to the northeast corner in about 7 hours. 8 hours.
There you go. Yeah. But they have a lot of wind power up in Minnesota, and they're having trouble because you can generate as much power as you want to, but unless you have a means of getting it to market, doesn't matter. And they have a transmission line bottleneck in southern Minnesota because, Rosemary, going to talk about U.S. geography for a minute. There's a sort of like a lake in the way. So Minnesota has to go down through Iowa to kind of get around to, well, sort of. You want to get to Wisconsin and to Chicago with that power, Indianapolis, those areas, and they really can't. So everything kind of going southern Minnesota can't get to where it needs to go. And what's happening is they're turning off wind turbines, the older wind turbines, and keeping the newer ones on, because the newer ones have production tax credits. So those wind turbines generate more revenue than the older ones. And the production tax credit rolls over in about 10 years. Joel, is that right? In 10 years, it expires?
Yeah, depending on which version of it you were on, it's a little bit different, but yeah, that's as a rule. Yeah.
Okay, so the older wind turbine sites are being shut off, so the new ones can make more money, and it's causing counties, which are participating in the revenue of these wind turbines, to lose a lot of money. In fact, 18 counties in Minnesota in their wind belt, quote unquote, reported a 14% drop in wind tax revenue last year compared to the previous year. That's a big deal, right? And they're trying to figure out ways to deal with this because if you can imagine, local municipalities become dependent upon that revenue. It's wind, right? It's pretty consistent. Why aren't we making money? And I'm sure they got that money already allocated to a new fire engine, a new schoolhouse, to whatever. And then to see a more than 10% drop in a year is a big deal. So Joel, have you seen some of this? Have you been around some of this where they're shutting off wind turbines because of transmission line issues?
Yeah, when you drive across southwestern Minnesota, if you drive at night, southwestern Minnesota, southeastern South Dakota, that corner of Iowa, all you see is red lights blinking in the sky.
Yeah.
There's turbines everywhere around there, right? So with that much power generation in one area, of course, the bottleneck is going to be the utility lines. Now, the other side of that over there is you would think it wouldn't be as hard to build them because if you've ever driven through there, again, it's all agricultural land.
Sure.
There's a stand of trees for 10 acres, and then it's another 2,000 of corn.
Right.
And that's basically what's there. And the major cities, right? You have Sioux Falls there. The next major city is Minneapolis, and then Des Moines to the south. So there isn't a whole lot of. It's mostly rural. So I believe that when they start, if they start to try to push some more power lines through the area, it shouldn't be as hard. The only difficult thing is too, I think some of the farmers, because I do some pheasant hunting and stuff out there, but some of the farmers they're a bit tired of it. They're getting to that not in my backyard, and they weren't originally. And because some of it is there's so many, they're literally taking over every chunk of farm that you see. So there's some people that are starting to get their hair on the back of their neck up a little bit about the wind development in the area. So it might be a little bit harder to push through some of these utility lines, but they need it big time.
Yeah, and for the first time in a long time, I've actually seen some action and a little bit of forethought here. That whole area, Minnesota, Iowa, Illinois, and then going all the way down south into, I think, Louisiana, and all the way north up into Manitoba in Canada. So there's like a north-south string of states that are all connected together. It's called the Mid-Continent Independent System Operator, is the MISO, is the grid that ties them all together. They understand that there's a bottleneck there, and they're trying to do something about it because all the solar projects, all the wind projects, all the renewable projects want to be close to the transmission lines. So everybody's stuck around these transmission lines, and they don't have enough to feed out. So they're planning a $10 billion project to expand the power lines. And so they have a couple, if you go online and look at it, there's a couple of lines extensions into sort of southern Minnesota, into Iowa, I think through Illinois. And they're talking about spending $10 billion to support up to 53 gigawatts of additional resources. 53 gigawatts is a lot of power generation. It's about twice of what the wind is in Texas that they're going to add capacity for. And with that $10 billion, they think they're going to get about $37 billion in benefits. So they're making trying to do the economics of this. Like, okay, if I put $10 billion in, what do I get out? Well, I almost quadruple my money in this project. So the concern is, how fast can you do this? They've been working on this for the last at least two solid years, and they're getting close to the process starting where, okay, we're going to get the green light and go ahead with it. So for that $10 billion to create these power lines, I was shocked at how many jobs it would create, or at least what they're talking about. And Rosemary, I'll even throw your 10% on this. So they're saying it's going to create 213,000 jobs to build the renewable energy and energy storage facilities. Makes sense. Plus another 120,000 jobs just to create the transmission facilities. That's transmission lines, towers, substation, switching, all the stuff. So in total, it's like 330,000 jobs. That's crazy. Joel, what's the population of Minnesota?
Well, Minnesota's about 7 to 8 million, and if you just kind of look, I'm looking at a map here of where they're going to put these lines. So 7 to 8 million there. I'm talking 7 in Wisconsin, 6 in Iowa. Well, Illinois has got a lot, but I mean, you're 50 million people, 40 million people in this corner of the world,
Ooh.
and 300,000 jobs. I mean, that's a big chunk of jobs that could alleviate some unemployment rate.
Oh, gosh, yes, it would. And they're saying with the 53 gigawatts of added capacity in the lines, it would be able to power 12 million homes. That's a significant impact for that area. Now, MISO thinks it's going to take between 7 and 10 years for the permitting and construction to get this all done. But they're working on it. And it isn't like they just came to the decision last week like, oh, we got a problem. They've seen overheating situations happen more recently. They've been watching the grid. That's what they do for a living. They're watching the grid and they're realizing, hey, we need to get this project started. So that's good. You know, it's good to see something proactive happen in the States where we don't feel like we're always behind the 8 ball. Because lately, that's what it feels like. It feels like no one's driving this bus.
I like the idea of this. Like, so I'm looking at this map, and it reminds me of what I saw with my own eyes happen in Texas. Is those big transmission lines that were heading out to West Texas, bringing all this wind energy, and all of a sudden, little solar, utility scale solar PV plants just started popping up within 5 miles of them all over the place. So when I look at these maps, I think, well, there's 2 or 3 difficult areas to build a power line on here. There's a chunk going up towards the northeast part of Minnesota. You get into some timber up there. Going across western Wisconsin, you get into the bluffs. That's a little bit difficult. But for the most part, all of this proposed lines go through agricultural land.
They do. That's right.
It's prime for popping up solar PV around it, and of course wind, as we'd like to see with some storage facilities. This could be great for the Midwest.
Yeah, let's just see how they're doing here and see if this project gets greenlit, because it does mean somebody's got to get raised at $10 billion, I assume, with electricity rates a little bit to do it. Yeah. But if the payback is 3 or 4 to 1, it really makes sense to do it. Good to see it. So I'll follow this and I'll check out some other parts of the U.S. on the electricity grid and see what they're doing too, because they can't be the only one that's actually working on projects. And that's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Be sure to subscribe in the show notes to the Uptime Tech News, our weekly newsletter, as well as Rosemary's YouTube channel, Engineering with Rosie. And Rosemary, do you have a highlight of what's coming up on your channel while we're here?
Yeah, I think next up is going to be actually a video that I recorded when I was in the US. I did a tour of Boston Metal, who are making a green steel manufacturing process, and they let me see. It was really cool, actually, because they've got like 4 different stages of development in their facility. It's actually in a business park. They're making steel in a business park, and they showed me all the development that they've done to take it from, what started out as an interesting result of an experiment at MIT, and now it's moved up to this semi-commercial scale process that is a way to make steel without any CO2 emissions. So it's pretty cool.
So get on YouTube, go to Engineering with Rosie, and ring the bell so you know when the next YouTube video pops up from Rosemary, and do the same thing for Uptime while you're there. All right, that's going to do it for this week on Uptime. We'll see you next week.